Hi, this is Synthchaser from Synthchaser.com, and today we're going to be troubleshooting and repairing this ARP Omni 2 synthesizer. So I've just gone through and done a general refurbishment of it. I've changed the capacitors, repaired any burned up stuff inside the keyboard on the electronics. I've replaced the sliders with the LED sliders, which haven't been turned on, illuminated yet. I refurbished the key bed. In the last few videos of restoring ARP Omni 2s, I showed you those steps in detail. I figured that would get boring if I kept showing the same thing over and over again. But in those videos I got kind of lucky, and after I did the general refurbishment, things seemed to work okay. This one I'm not quite so lucky. So for the strings I've got viola. But violin is dead. The cello and the string bass, they're working okay. Over on the synthesizer, the 8-foot polyphonic synthesizer is working okay. But the 4-foot synthesizer is dead. The synthesizer bass is working okay. So we have a little bit of troubleshooting to do, and what I'll do is I'll open up the synthesizer and we'll take a look. I'll give you a general overview of what could go wrong to cause dead voices. I'll call these voices, like the 4-foot synth and the violin would be voices, and in this case these two are dead. And there's a number of possibilities for what could cause this, and I don't like to just guess and check on things. I like to figure out what's wrong before I make a repair. So let's open this up, and I'll give you a general overview of how this works and what could cause dead voices or dead ranges of keys on the ARP Omni or ARP Omni 2. So as I mentioned, I don't like just guessing at problems and changing chips on a whim and seeing if that fixes things, because there could be any number of problems. I mean, it could be a failed chip, it could be a broken connection, it could be a cracked solder joint, it could be, like I said, any number of things. But there are a few things that I can make as an educated guess for what might be causing this problem. But before I talk about this particular synthesizer's problem, I'll kind of give you an overview of where things could go wrong to cause missing voices or ranges of keys. So there's a few differences here on this keyboard versus other ones. I have these dangling wires with electrical tape. That's for the power for the LED sliders, which I haven't hooked up yet. I want to make sure that the synthesizer is working all correctly before I connect these power wires. And then close it up. The other thing is I've removed the master oscillator section here of this keyboard. There's an adjustable tuning coil here, and when I got to restoring this synthesizer, I don't know if you can see it, but there's like a little burned up area where one of the components had fried. So I replaced the whole master oscillator section with this, and we'll talk about this in another video perhaps. But if you're not getting any sound out of your ARP Omni, I mean, that's one possibility, is that the master oscillator has failed, or the top octave generator chip has failed. So this is basically a clock that drives this top octave generator chip, which generates the high octave of notes. They are then divided down by these chips. So if you're getting, if you're missing a few notes, it's possible that one of these chips has failed. If you're missing all your notes on all the voices, it's possible that something in this section has failed. So then waveforms are made for each of the notes on the keyboard, and they're controlled by these transistor arrays, which sum them up when you're playing multiple keys. So if you're missing about 10 keys on a 4-foot or an 8-foot voice, it's possible that one of these transistor arrays has failed. And the keys that work on your 4-foot should work on your 8-foot, because there's different chips for the 4-foot summing and the 8-foot summing. and there's chips here on this board and this board that do that same function. So in this case, we're missing an entire range, the entire keyboard worth of 4-foot string and 4-foot synthesizer voices. So what the odds of all of these all 5 of these transistor arrays having failed is pretty slim, and we know the master oscillator is working because I replaced it with my thing, and the top octave generator is working because we hear some notes coming from other voices. So I'm pretty sure that there's no problem here. The next area where there could be a problem is over here. There's a dual op amp right under this connector that basically takes the output from the 5 4-foot transistor arrays and the 5 8-foot transistor arrays and sums them together. It's a possibility on this keyboard that because the 4-foot strings and the 4-foot synth are both broken, that this op amp could be bad. So that's the first thing that I'm going to take a look at when we actually get down to troubleshooting. Another place that's common to lose entire voices are up on these boards, the synthesizer and string control boards, and there's a few 4016 CMOS analog switches. So basically when you press the button on the front of the keyboard, it toggles that on and off and either allows or disallows an audio signal to pass. And they're a common failure point. They can introduce noise or other artifacts into the sound if they fail. So in that case, this is a possibility here as well, that one of the 4 switches on the 4016 failed on this board, and another 4016, only one of the 4016 switches failed on this board too. So that's possible, but less likely than having one of the 2 op amps on the dual op amp chip fail. So that kind of gives you an overview of where you can go to look if you've got dead or dead voices or missing ranges of keys or no output at all. That's not a comprehensive list of where you can find the problems, but those are common failure points. But like I said, it could be anything from a cracked solder joint, a bad connector, something plugged in backwards. It could be any number of things, and I don't advocate just changing chips randomly to try to fix things. I mean, you can wind up doing more harm than good that way. So what we're going to do is we're going to take a methodical approach to solving this. And like I said, since we know that we're getting sound, the master oscillator, the top octave divider is fine. The odds of all 5 transistor arrays having failed, 3 on that board and 2 on that board, are slim. But we'll start looking here at this op amp, and we'll see the input to the op amp and the output to the op amp, and we'll see if the audio signal is making it to this point, and if it's being lost at that point. So let me get set up with the oscilloscope and we'll have a look. So right now I've turned on the violin and the viola, which is the 4-foot and the 8-foot strings, and I only hear the viola, which is the 8-foot strings. So let's go take a look at this op amp. So this op amp here, as input, takes on the non-inverting input, takes all 5 of the transistor arrays, the output of those. So it takes an audio signal in and it amplifies it and buffers it and passes it on to the rest of the synthesizer for processing. So let's take a look at the 8-foot strings first. So we're going to take a look at the input. So this is the non-inverting input of the second op amp on this chip here. So that's what the audio signal looks like, and I've got it AC coupled. So there's a small audio signal there. It looks like about maybe 200, 300 millivolts peak to peak. But we can definitely see an audio signal there when I'm playing. So now we're going to look at the output pin for this op amp, and let's try to get in there without hitting the wrong thing. So there's the output. Again, looks like an audio signal, just like maybe like 2 volts peak to peak. So we see an audio signal on the input, the non-inverting input, and we see an audio signal, a larger audio signal on the output. So now we're going to take a look at the first half of this dual op amp chip, which is the 4-foot string, or the 4-foot polyphonic voices. And if there's a problem before here, we won't see the little 300 millivolt signal on the non-inverting input. So let's take a look at that. That's pin 3 of this op amp. So I do see an input there. So already I've eliminated pretty much everything with the gating and the transistor arrays and all that stuff. Let's take a look at the output and see if this is going to be a short video and we just have a bad op amp here. So the output is pin 1. And we actually do see an audio signal as the output. So I thought we were going to have a pretty short video because they're both, the 4-foot voices were dead, and this is a path that they have in common, but that appears not to be the case. So the next thing that I'm going to look into, the next most likely culprit, would be the analog switches on the string and synthesizer control board. So we're going to take a look at those and see if they're properly allowing the signal to pass, and if the control line is telling it to be open and allow a signal to pass, or if there's some problem with that. So I will adjust the camera so you can see that, and we'll go from there. So this is going to pose for a filming challenge, because I've got to press keys on the keyboard, poke things with the oscilloscope, and not block anything so you can see. So I'm going to try my best here. So what we're going to do is now we're going to check these analog switches on the, we're going to do the string control board first. So I've turned off the viola, and I just have the violin as the only voice I've selected. That's the 4-foot strings. And I press, and actually I can hear very faintly the sound of the strings, but it's nowhere near the volume it should be. For reference, here's the viola. And here's just the violin. So something maybe is getting through a little bit, but it's definitely not working correctly. So we're going to take a look at the analog switch, and what that does is it's a bidirectional switch that either allows a signal to pass through or doesn't allow it to pass through, and it's controlled by a control line. So there's an input and output, which are interchangeable, and a third pin, which is the control. A high means it's open and it will allow a signal to pass through. A low means that it's going to open that up and not allow the signal to pass through. So for the 4-foot strings, we're going to be looking at the Z1, integrated circuit Z1 on the string control board. And we can poke the bottom of this board while it's mounted in the keyboard. So first thing we're going to do is we're going to take a look at the control line. So I have it turned on, the violin voice turned on, so it's a high signal. If I toggle this, so I turn violin off, it goes low, turn it on, it goes high again. So the control input is being correctly supplied to this analog switch. Now let's see if the signal that we saw coming out of that op amp is even making it here to this analog switch, or if this problem is somewhere else. So the input is pin 1. So I'm going to press some keys, and there's the input. I've changed it to DC coupling and 5 volts per division, so that's why the signal looks a little different than it did just a moment ago. But I definitely see the signal there. Now we're going to look at the output. So since the switch is turned on, whatever is coming in here should be coming out on pin 2. So let's test pin 2, and it's not. So so at least for the violin, the problem appears to be one of the 4 switches on this chip has failed. And again, these are a common failure point. That's why I kind of honed in on them first. I went and looked at the op amp, and the CMOS chips are common failure points. So I didn't need to track this down like from the very beginning of the signal here on the near the master oscillator. So now let's take a look at the 4-foot synthesizer voice, and we're going to do the same test over there on the synthesizer control board. So I'll move the camera so you can see that. So we're going to repeat this little experiment that we did on the string control board over here on the synthesizer control board, and there's another 4016 analog switch buried underneath here that does exactly the same thing. So we're going to repeat the test, and again we're going to check the control line. So let me get my finger on the button here, and so pin 13 is the control. So I have it turned on, I turn it off and it goes down to 0, I turn it on, it goes back up to 15 volts. So even though it's on, I'm not hearing anything. So the next thing we're going to need to do is we're going to see if an audio signal is even making it to this chip, or if there's a problem somewhere else, like the voltage controlled filter or something like that. But I'm pretty sure the voltage control filter is fine because it's working on the 8-foot synthesizer voice. But anyway, in this case, the pins are swapped. So the input is coming onto pin 2 instead of pin 1, and then it's going to the output. So let's check pin 2, which is the input. I'm going to press some keys, and I do see an audio signal there when I press the keys. And we'll check pin 1, and we'll see if it's making it out of here and the problem's somewhere else, or if, again, we have a bad switch chip. And I just slid off the, there we go. So I'm pressing the keys and there's nothing. So it looks like it's coincidence, but the analog switches for both of those voices have failed. So what we're going to do is we're going to pull these boards out and we're going to change the chips, and we'll come back and we'll take a look and see if that fixed the problem. So I've changed out those chips we talked about, and I'm going to show you what the new chip looks like under the oscilloscope. So we're going to look at the synthesizer control board, and I have the 4-foot synthesizer turned on. So I'm going to look at the control line here, and it's high. And I'm going to look at the input, which for this one was on pin 2. So you see the signal there. And the output was on pin 1. And it's the same as the input. So now this switch is working correctly. So we have the 4-foot synthesizer section working by changing the switch chip on the synthesizer control board. And the violin, the 4-foot strings, is now working as well from changing the chip. But we knew it would because we did the troubleshooting with the oscilloscope and tracked down the exact problem. I understand not everyone has an oscilloscope or knows how to use it, and so this kind of methodical approach to tracking down problems with synthesizers just isn't practical for some people, and you do have to guess and check. But hopefully I showed internally where there could be problems, which chips would be suspect, if you were missing voices or ranges of keys on the keyboard, and it'll give you a head start on troubleshooting or just guessing and replacing. And I do sell a kit of replacement chips for this synthesizer. Some people that don't want to track down the issues or have a lot of problems just replace all the chips in the keyboard, and that's perfectly fine. New chips are going to be more reliable than the old chips from the 70s. And those kits are available on my website, synthchaser.com. But again, we showed you how to troubleshoot this type of problem, where most likely culprits are, and now we've got this keyboard working. So I'm going to finish it up and calibrate it and hook up the LED sliders, and then this will be good to go. So this is Synthchaser from synthchaser.com, and thanks for watching. If you have any questions, please post in the comments or contact me through my website. Thanks again. Bye.